Okay, so now previously we have looked at the supervised learning and on regression. So in addition to the regression, now the second most commonly used supervised learning problem is a classification problem. Classification. And under classification we have several algorithms that are there. So when we are currently in the subject matter of supervised learning, which means we have a target label that we actually want to do the prediction. So previously we have seen when we are having a continuous value, then we can actually use regression. But when we actually comes to a output label that have a discrete sets of values, then we need to use classification. Now the first example that we're going to use is we're going to look at logistic regression. So here are some of the classic algorithms. Logistic regression is what we're going to see, and then we will look at nearest neighbor classification, naive Bayes classification, and decision trees. These are all the supervised learning algorithm which falls under the classification field. So we're going to look at that. So basically we're going to use all these algorithms when you have a small set of classes or discrete labels that you actually want to predict. So this is using the supervised learning and classifications. So when we look at logistic regression, let me see, where is the chart? So long now. I think let's look at this one. Yeah. Okay, let me just do the explanation first. So looking at the logistic regression, of course, this don't be, even though it has the term regression, the term logistic is actually a classification method. So it's one type of a linear classifier because it has some similarities with the linear regression. So later after this, I'm going to show a chart. So this explanation on logistic regression is very, very important. So how logistic regression is done, and the formula of a logistic regression, and also the graph of a logistic regression is very, very important. So how do we actually convert a linear regression problem or a linear function into a logistic regression? So this type of classification, it actually uses a logistic or a sigmoid function. So this is a sigmoid function, 1 over 1 plus exponential of function of the value of e by the power of negative x. So we are taking the exponential value. So when you look at the sigmoid function, so these graphs are this formula and these graphs are very important. Let me just try to enlarge this a little bit. So here is an example. If you have a linear function, here you have a linear function. This is the student's marks with respect to number of hours studied. So given here is a linear function y equals mx plus c, and you can see the marks here currently is in a continuous function, right? So if this is the problem, we can actually use the linear function, linear regression. But because the marks are not categorical, they do not have a classification, so it's when you want to make prediction what is the marks, it's very difficult for you to get accurate marks prediction for that. So how we can actually manipulate this is, logistic regression basically means it's trying to measure the relationship between the dependent variable. So dependent variable means, let's say we are looking at the marks, what we actually want to predict with one of the variables, which is, it could be a feature. So in this case, we can actually look at marks with respect to number of hours studied. So when we actually use the logistic regression, we are trying to find some sort of a relationship between the marks and also the number of hours studied. But if you just look at marks, there's a continuous function of these marks. So it's very difficult for you to actually try to find or measure the relationship. So, but when you actually apply this sigmoid function, when you take this x values and you substitute here in the x values, then you can actually, when you substitute uh, here, of course, this function is actually the y values. When you substitute it, you'll actually get this kind of function, this kind of sigmoid function. So you see this kind of sigmoid function, but it's actually based from the linear function. And you change this into a probability to have a binary kind of or two class of output, either the student pass or the student fail. And this is still the number of hours. So now instead of having this continuous range of values, now by applying the sigmoid function, we are trying to estimate the probability using this sigmoid function. So the probability of students passing, we make it 1. If it fail, is 0. And this sigmoid function has this particular kind of curve. So there is this center of this function which is for somewhere here. So from this function we can see if the number of hours students studied from this number of hours up to this number of hours, most likely higher chances for the students to fail. But if they study from this point onwards, more they study, the higher chances of the students to pass. So now you see from the continuous function, by applying the sigmoid function, it actually changes into a binary or two-class classification. So this is how we actually apply the sigmoid function now to create the probability or create a class. So the classification of the output variables is based on logistic regression is actually fast, and its results are very easy to interpret. So in this case, you can see the number of hours studied with respect to pass or fail. So if they are studying from this number of hours up to this point, so this is like where it changes from 0 to 1, so which is 0.5, right, which is somewhere here under the sigmoid curve. So any hours that is from here until here, they are at higher probability of failing, whereas from here, which is that means the center point from here to here, the number of hours, there are higher chances for the students to pass. All right. So, in order for us to implement the logistic regression, we can import the libraries and packages. Just hold on. So we're going to import some of the libraries. So we're going to import. We're going to have some plotting, so we can actually import the matplotlib, pyplot. So these are all the standards function that we actually import. Then we import numpy as np. Then from sk scikit-learn, we are taking from the linear model. We're going to import logistic regression. Earlier it was linear regression, right? So now it is logistic. Take note of the capital L and also R, logistic regression. And from sklearn, we're going to metrics. From the sklearn metrics, we are going to import the classification report, so which allows us to give the outcome. And also we're going to use the confusion metrics. These are some of the things that we'll be covering in a later point of the chapter on the classification report and the confusion metrics. So let's run them. Okay, all the libraries are fine. Sorry. So let us actually write the following script to generate some data for classification. So basically we need x and also y values, right? So the x values, we are going to use the numpy. We are going to create a range, sorry, forgot, range of 10, and we're going to we are going to create a range of value from 0 to 9. Whenever you put one single value, that's the end value, and we're going to use the reshape function. So reshape function, whenever you use -1, that means you are not going to separate them. So when you use -1, usually the reshape function takes two arguments. The first one is the number of array and also how many elements that you want to be in each array. So when we want to have one element in every array, we have to use -1. So indicating that we allow every single element to be in all the arrays. So meaning to say, if we do something like this, then if you view x, so you can see that this is one array, this is 2 and things like that. So usually we have to specify the number of array, but if you use -1, it automatically will assign the number of array with one number in every array. So this is one array, this is 2, 3 and things like that. Okay, so that's what we're doing for the x, and for y, let's also use that. Now we actually create an array, because y is where we are going to be our predictive target or the label target, right? So we just assign the output. So currently we need to have 10 output value. So let's say if you put 0 0 0 0, and then you can just put 1 1 1 1 1. Wait, how many ones are there? This is 2 4 5 and 6. So if you view the y, you can see the y array. So we have actually got this x and y value, and just to get some visualization, let's try to plot the scatter, and just for you to have the visualization. Sorry, not plot, it's PLT, right? Yeah, so this is our points. This is our x value and this is our y value range, which is 1 and 0. So you can see there are two different distinctive class that are here, right? So now we are going to come up with the logistic model. Where should the curve come so that it will be able to best represent this value 0 and also 1. So if there are some other values that fall from 0 to the center of the sigmoid function, so it will be classified as 0. If it's more on is above the center of this point, the coefficient, then it will be classified as 1. So what is the curve, the sigmoid curve? What is the best sigmoid curve? That will actually use the logistic regression to find out what is the best sigmoid function. So we initialize the logistic regression model, and we use it for training by specifying the input and output variables. So we're going to have our model, we're going to create our model, and we're going to use the logistic regression, and we're going to use a solver name. This is liblinear. So this is actually the liblinear is actually is a logistic regression model. There are several solvers that falls under the logistic regression. So one of it is the liblinear solver, and this is liblinear solver is actually good in solving large scale linear classification problems. So it's quite a famously used solver, and we are going to allow the random state to be 0. We're not going to specify what is the starting point and things like that. We're not going to allow it to start from random point, and we're going to provide the x and y value to the model to fit the model. Okay, so let's run this. So you can see the outcome. It actually gives, this is the logistic regression with random state 0 and solver using the lib linear solver. So if you, let me see if I just type model. Okay, sometimes it shows maybe the old one, it shows more detail about this logistic regression model. That's fine. So here we have actually run the model. Yeah, we've already run it. It actually shows that this is the solver that will be used. So to print the attributes of the model, we can actually write the following script.